Hello guys, if you have been new here, in my past videos I've been talking about the history of programming languages, so you can go and check out my other videos and you learn a lot about programming languages. So today we'll be talking about Rust. Every programmer knows the fear. You write 1,000 lines of C or C++, it complies, it runs, and then in production at 3 a.m. it crashes because somewhere deep in the heap a pointer pointed to a place it shouldn't have. Memory unsafety. It is the original sin of systems programming. For over 50 years, we just accepted it. That's the cost of power, we said. Then in 2006, a Mozilla employee named Graydon Hoare got mad about an elevator bug in his apartment building. His frustration didn't just produce a bug report. He produced a new language. This is the story of Rust, a language designed by a perfectionist, adopted by a community of refugees from C++, and so beloved that it has become the most admired language in the Stack Overflow survey for 9 consecutive years. It almost died. He had no money, he had no weird mascot, but he survived. Here's how he survived. In 2006, Graydon Hoare was working at Mozilla, the makers of Firefox. Firefox is a massive C++ code base. C++ is fast, but it's also a minefield. You have to manually manage memory. Forgot to free something, memory leak. Freed it twice, crash. Use it after freeing it, security vulnerability. Roughly 70% of serious security bugs in software like browsers and operating systems are memory safety issues. Graydon had a side project. He was frustrated that his building's elevator was constantly broken due to buggy software. So he started designing a language that could prevent these classes of bugs at compile time. The compiler wouldn't let you write unsafety memory code in the first place. He called it Rust, not a reference to iron or durability. It was named after a group of fungi that are robust and resilient. Plant pathogens, a weird origin for systems language, but it fits anyway. So Rust's core innovation is a concept called ownership. In C, you have a pointer and everyone can point at the same memory. Chaos ensues. And in Rust, every piece of data has exactly one owner. If you pass it to a function, you either move the ownership, borrow it temporarily, or copy it explicitly. This is enforced by borrow checker, a part of the compiler that acts like a brutally strict librarian. You want to read this book? Fine. You want to write in it? You need to check it out, and no one else can be reading it while you do. Early Rust was infamous for making programmers fight the borrow checker. But here is the trade-off. If your code complies, you know with mathematical certainty that there are no data races, no use after free, no double free. The compiler is also famously helpful. It doesn't just say error. It says, hey, I saw you try to use this variable after it was moved. Here is a suggested fix, and here is a link to learn more. Mozilla was interested. They were rewriting Firefox rendering engine called Servo, and they needed a language that was fast, parallel, and safe. Rust went from a side project to a sponsored Mozilla research project in 2009. But it still had a research toy, a very slow, unstable research toy. Now, many memory-safe languages came before Rust. Cyclone, BITC, and others. They all died. Why? Because they were academic projects. They weren't practical. They required a PhD to understand, or they were too slow, or they didn't have a killer app. Rust almost joined them in the early 2000s. In early 2010s, the language changed constantly. Code written in Rust 0.4 wouldn't comply in Rust 0.5. The community was small. It was a fascinating experiment, but nobody was going to bet a production system on it. Then a few things happened. The community rallied around a project manager called Cargo. It made building, testing, and sharing code easy. That it removed the friction that killed other languages. And the community started a phase that became a meme and a mission. Rewrite it in Rust. Command line tools like Rich Grip, a code research tool, and FD, a file finder, was rewritten in Rust, and we are blazingly fast compared to the C or Python counterparts. The meme was real. Rust wasn't just safe, it was fast, like C++ fast, sometimes faster, because the safety guarantees allow for aggressive optimization. The turning point came in 2015. Rust hit 1.0 stability. A promise that your code will keep working. Mozilla shifted. The community started growing exponentially. Here's where the story shifts from cool project to industry standard. Big tech companies started noticing that the languages they used for decades, C and C++, were the root cause of massive security vulnerabilities. Microsoft analyzed their security bugs and found that approximately 70% of it were memory safety issues. They started adopting Rust for new components in Windows. Google started using it in Android. Amazon Web Services built critical infrastructure like Firecracker, the virtual machine monitor that powers serverless computing in Rust. And then in 2022, the unthinkable happened. Linus Torvalds, the creator of Linux, the man famous for being opinionated about C, agreed to merge Rust into the Linux kernel. The Linux kernel is the foundation of the internet. It's millions of lines of C. For decades, Linus rejected C++ for the kernel, but he accepted Rust for the very first time. Not to rewrite everything, that's impossible, but to write new drivers and modules in a language that wouldn't introduce more memory bugs. It was a validation that echoed through the industry. Rust had just made it. Rust mascot is a fluffy orange crab named Ferris. It's a strange choice for a systems language, but it reflects the community's personality. Rigorous on the inside, welcoming on the outside. The language has its critics. It's not easy to learn. The borrow checker has a learning curve that makes people want to throw away their keyboards. Fighting the borrow checker is a rite of passage. Some say it's overkill for simple tasks. The comply times can be long, but the community remains the most passionate in programming. For 9 straight years, Rust has topped the Stack Overflow developer survey as the most loved language. 9 years, that's not hype. That's a genuine consensus that the pain is worth the reward. Rust is now everywhere, in the browser via WebAssembly, in embedded devices, in blockchain, in code infrastructure. The language born from a broken elevator now powers critical systems that run the world. It took the best ideas from functional programming and systems programming and welded them together with a compiler that acts like a peer programmer, not a gatekeeper. The elevator still breaks sometimes, but the software that runs the elevator is a lot more likely to be written in Rust now. Graydon Hoare didn't set out to create the most loved language in the world. He was a frustrated programmer who wanted to make software that didn't crash, but that frustration channeled into a world of obsessive design and community that refused to compromise on safety, changing how we think about systems programming. The next time you open a terminal and run a Rust program or Linux kernel module, remember you are running code that the computer has verified line by line to be memory safe. You are standing on the shoulders of a crab. Thanks for watching.